Hello, everyone, and welcome to today's webinar. My name is Jesse, and I'll be your host today. Today's webinar is being presented by Earl Beede, a senior fellow and software estimation expert here at Construx. This webinar is being recorded, and I'll send you an email once that is available. Usually that's within 24 to 48 hours. Feel free to share that recording with your colleagues and friends. We really appreciate when you do that. We plan a short Q&A at the end, so feel free to ask your questions throughout the entirety of the presentation. Earl, thanks for being here. I'll go ahead and turn it over to you now.
Well, thank you, Jesse, for the introduction and allowing me quickly to learn that my microphone had flipped itself. I'm Earl Beede from the Quarantini, I guess, if we have to put it that way. Welcome to today's webinar. My topic today is 3 estimation types. A little bit of housekeeping before we get in there with today's tech. Jesse, I think you mentioned it, but we do have Q&A turned on. So throughout the presentation, please submit your Q&A questions. You should see a little icon up in the upper right-hand side, I think, that has the Q&A button on it, so you can submit questions there. Because we're using our technology as Microsoft Teams, you can actually pause this presentation, go get a cup of coffee, come back and pick right back up. You'll be a little bit more behind me, but if you look like I'm frozen for some reason, it could be you just hit the space bar, so be aware of that. It does have a nice ability to pause there, which means you can go back and play it again. And we'll be putting this up probably, I think, on YouTube later, so you can get it there as well. So what am I thinking about? And hopefully, what are you thinking about when we think about these ideas of estimates and 3 different types of estimates? Well, what I really want to start thinking about, and what I have to do with a lot of my clients when I go out there and I coaching them on estimation, or I'm training them on estimation, or even reviewing the estimates that they're coming up with, I first have to get them thinking about estimates as a probability of some kind, that there actually is a probability function that the estimate's doing. Then once we get the idea of the estimate as a probability function, then we can start talking about these estimate types. And I want to talk about 3 estimate types, or think about them with you here, and have you sort of resonate and say, how does maybe affect the kind of work that I'm doing? And then I'm going to go through those 3 types, and I'm going to give you a bonus type, the go, no go, and then we'll wrap it up. Oh, I also want to mention, hopefully you see here, I'm rocking Bow Tie Tuesday. I've been doing Bow Tie Tuesday now for several years because, hey, I can. I got lots of bow ties I've collected over the years because it makes a relatively unique gift. And so I thought, what the heck? I'm not going anywhere because I'm in quarantine, and might as well just let me break up the week somehow. So thank you for indulging me. So this is what I'm going to be thinking about here going forward. So let's go ahead and get into it. And first thinks about estimate as a probability. And this is really kind of critical, because until you really sort of grasp this idea of it being a probability, it's really hard to say what is a good estimate versus a bad estimate. And you'll make it very hard and very frustrating as you try to think about how does particularly Agile use estimation. And we'll go into that a little bit here. So let's look at estimate as probability first of all. So here is my probability distribution, and on this I got my little doodle pad here. On this top axis, this is going to be our probability. Now, when we talk about this axis, it's not going to get very high. In fact, the biggest number here is not very high, because I'm going to try to draw a curve here that is on a particular point in time or a particular cost. So it's not going to get very high. Down the bottom, let's look at time or cost, right? Because that's what I want to write down here at the bottom is time or cost. So now we can draw a probability distribution. And for time and cost, the probability distribution looks often something like this, right? That I've got a couple features of this curve here. Right? One is that I have a minimum value, that it's going to take some amount of time or some amount of cost to do something. And the chance it can take exactly a certain amount, it still does not get very high. So the probability never gets very high, but there is at least a minimum here. That's going to take some amount of time or cost. On the other end is infinity. And that is, there is some possibility, even though it's vanishingly small, there is some possibility that you could spend all the money in the world or take all the time left in the universe, right? It could happen. It probably is not, though, because it probably gets really, really small because that approaches 0 and stays really close to it, to an extremely small event. So I'm going to invoke my magic cleanup process here and clean up this so it's a little bit more readable for you. But so here is what we think about when we say a probability distribution. Now, I want to be careful because this is sort of a middle of the road distribution. How it looks at any point in the project can obviously change. Particularly very early in the project, what we'll see is that it sort of widens itself out. That is, it pulls itself apart, and so that we don't get a very high probability of almost any date, because it's so wide, because there's tons and tons of uncertainty in the project. So our curve will just stretch out to lots of possible dates that have equally low probability of actually happening all the same. In a similar fashion, as we move up near the end of the project, we get near the very end, or even 3/4 of the way through, we're going to see that thing narrow quite a bit. In fact, this might actually become a high number, so we can sort of cross that out a little bit. We might even get something in the 50-60% range, right, rather than the 1% or 0.5% range. Because as we get further and further on, hopefully we have much less uncertainty, and so that curve can really kind of squish. But we'll just sort of stay here with our sort of middling curve here, because it's easier to talk about our 3 estimation points. So we got our different types we want to talk about. So what are those types? Well, what we do when we talk about an estimation type, what we're really doing is saying we need to pick a point on this curve. We need to say somewhere on this curve, this is where we're going to choose. And the first point we like to choose when we start thinking about picking these points, the first point I like to choose is a place that we often call the nominal point. The nominal point is a point that if we pick that point in the curve, we find that point that intersects the curve, then we start doing some calculus of the area under the curve where we drew the line. And so we would say, well, if we did the calculus, we find that 50% of the area is on here. So what we're saying at this point is we have about a 50% probability of being on or before this date, right? So on or before. And we have a 50% probability of being after this date. So our nominal is the point on the curve where we're 50-50. We're equally likely to be before as after. Now, a lot of people like this point in the world of estimation because it makes combining estimates, it makes conversing about them, it gives them a common point of reference. And so we often use this as professional estimators to sort of express an estimate. But the estimate is the entire curve. It's not just this one point. So we have to call it the nominal point. Another point that we tend to like on this curve is a point that we often call the worst case. The worst case is out on that tail a little bit there, and if we do the calculus of the area, we'll see that something like 90%, or some people use 80% of the area is on or before, right? So we're at 80, we're at 90%, 85%, something like that, and 10% of whatever's left over is after the curve. This is a point, it's often called worst case, because you've got to think about, wow, what's all the things that often go wrong here, and some of the things that kind of go wrong here, and all those go wrong this time. What's the worst that can possibly happen? And 9 times out of 10, you'll always beat that number because it's worst, right? And so that's a point on the curve that's pretty common. There's another couple points on here that are pretty common. One other point here is what's often called the best case. The best case says, here's a point on the curve that if we actually did the area of the curve, we'd only see that that's only about 25% of it is on or before, which means that we have a pretty good chance of not hitting this number, being on or before, right? That means we have, in this case, 75% chance. We're pretty darn likely to go over that number. And so it's an interesting point on the curve for the most part, but it doesn't do a whole lot for us, right? Because there's very little chance of hitting. You wouldn't want to promise that to anyone else on the planet. So that's the 3 points we typically use. Now, you may have heard one other point on here that you may have run into. If I just sort of pencil it out here, it's called the most likely point or most likely case. The most likely case is the case out here where it's the highest possibility. Now, it's not got very high to begin with, so it's not like it's a great shot, but it's the most likely case. So those are the things I'm going to be playing with here to try to come up with these 3 different types, right? And one of the I forgot about my question mark here. One of the things I'm concerned about is when we talk about most likely, we don't know what the distribution of that is. So we can't really use it nearly as well. We've got pretty good studies that say the worst case should be around 90. We got a lot more studies that say your best case typically is around 25, 75. But most likely case, it's not often perfectly 50-50. It's often before the nominal, a little more optimistic. So we really can't use that for a ton of stuff mathematically. But those are the points I'm going to be playing with here as we go forward. So as I think about this, now I want to think about our 3 different estimation types. And I want to use my curve to help fluctuate those out. So my first type here are ambiguity estimates. ambiguity estimates are estimates that we use to identify ambiguity. And so how we can play with this? Well, what we're going to use is we're going to use our best case point, but I'm going to rename this my ambiguity type estimate. Because remember, right, as we're talking over here, that this area over here is only about 25%, right? We said 25%. And so this is not an estimate that's going to happen. In fact, we have a really good chance of ending up over here somewhere, over in this zone of we exceeded that point. So how is this going to go do this? Well, certainly when we talked about making a promise, since we are likely over here, but we're choosing this point here, we don't want to promise this. This is not a promise by a long shot. And in fact, I don't think it's even good for making plans. But it does have one good thing going about it. Because when we look at this number right here, right, we can take this point on the curve, this is where our gut really comes into play, right? Our gut says, hey, I think it should take this much. In fact, it only should take this much, right? This has happened to me a lot of time in my personal life where I've gotten something that needs to get done and my wife will say, how long is that going to take? And I say, well, it should only take, and it takes always longer than that. That's this kind of gut feel. That's what's driving this point on our estimation curve, which makes it really, really easy to come up with this point. We don't have to do any math. We don't have to do any analysis. We just look at the work and go, what is our gut telling us? Okay. So what we like about this is that it's super, let me turn to my pen color here, easy, right? This is the easiest one we can possibly get. And this is where I almost start all my estimation practices because it gives us a point on the curve. So in formal estimation and doing formal estimation work, this is my starting point. That's about it. However, it's good for one other thing, and that is why I call it the ambiguity type. What it's good for is I can start saying to my two workers here and saying, hey, let's look at a piece of work and do we understand the work the same way? Right? Because I need a fast and dirty check often, especially if I'm doing often agile development. Do we see the work the same way? So what I'm going to do is I'm going to draw a box here, right? And I'm going to say, oh, we got two developers and we're trying to work on this box together, but we first ought to make sure, do we understand the box the same way? So this developer will look at the box and say, oh, I think that's 13 story points or something. And that other developer looking independently of the box would say, I think that's 2 story points. Well, right away, we can tell that these two people do not see this work in the same way. One sees it as a whole bunch of work, and one sees it as a trivial amount of work, which means we need to have a discussion between these two to actually start thinking about, tell me why you think it's only that much work. Now, if we had come in here and this person said, you know what, I think this is an 8, and this person says, yeah, I think it's an 8, we probably see the work the same way. Now, is it truly in its heart of heart an 8? We don't care. We don't care what it truly really is, because what it truly really is immaterial to the ambiguity that we're trying to expose. So estimation is being used as a way to expose ambiguity and force conversations. It is not a way, because remember, we're using our highly probable point here, this easy point, this gut checkpoint here. We're using that to come up with it. So we're not trying to make a promise with this. We're not even trying to plan with this. We're trying to say, do we understand the ambiguity of this? And if we have agreement between our two main partners here, then yeah, we probably see the work the same way. If we see someone come up with a radically different number, then we got to say we have to have a conversation. Okay. So this is looking at a piece of work, and this work can be a story. This work could be an epic. This work can be a project. If two people doing their gut estimates that are reasonably well-versed don't understand it, they'll force a conversation. And here's another bonus trick I want to give you. If you're this developer and you say, you know what, I've never seen anything like this before in my life, right? This piece of work, I have no clue what to build it. Yet we're supposed to act as a team to build it because we're running Scrum. Well, then I'm going to give it a 13 regardless. Because a 13 is basically saying, I don't know what this is. This looks really big and scary. We've got it sort of queued up for the sprint, but I think it's big and scary. Explain to me what it is, right? And that's going to, again, force the conversation so we all can learn, understand the work the same way, right? So when do I use ambiguity estimates? I like to use ambiguity estimates, really, I mean, let's face it, right, to find ambiguity. That seems like a killer deal right there, right, to help find ambiguity. And this is how particularly things like story points are supposed to work, right? If you're using story points to equal, one story point equals like 1 effort hour, or one story point equals half a day, you're not doing story points the way they were intended, in my opinion. They were intended primarily to find ambiguity. That's why you'll see a lot of the agile gurus saying, you know, we shouldn't even do estimation, but they'll talk about doing story points because they're not doing estimations to make a promise. They're not doing estimation to make planning. They're just trying to come up with it. So we use it for story points. We use it in task hours. It'll work just as well there. You could also use it at bigger items, right? You can use it in t-shirt sizing. So you can use it whenever you really want to focus on finding ambiguity. You could also use it as a base to get other estimates, because what I'm going to suggest is that this is an easy way to get a first estimate. And then we can start using some sort of math to get our other estimation types out of this. So we'll start here, but we got to be careful when we start here because we don't want to stop here if we're trying to do something else with this. In fact, we may want to start here, move to something else, and then erase this as quickly as possible because it's really not good for much else. And this gets a lot of people in trouble. A lot of organizations, and I go in there and they say, Earl, our estimation's suffering really badly. And I'll say, tell me what's going on. And say, well, we have our developers following Scrum techniques. We're using planning poker, and they poker a story, and we told them a story point equals 1 staff hour, so you know you're playing poker. But the technique of planning poker is really trying to drive the gut estimate ambiguity process, not the promise process. So they're using their guts, they're coming up with threes, and it's all getting messed up. And I got to say, well, then time out here, right? We can't use ambiguity estimates for much else. You can help them define ambiguity, but we're going to have to do some additional work. And this is where items like velocity and other things come in really handy to calibrate that into what's really more of a planning number that we could use going forward. So be careful here. You may want to make sure that if you do ambiguity estimates, and you should, because it's really, really handy when you're trying to work as a team, right, for the story points and task estimates, to make sure that it doesn't go beyond being just for ambiguity. The second of my estimation types I wanted to sort of look at here were promise estimates. And for promise estimates, we're going to go to that worst case, but I'm relabeling it now promise. Now I'm calling it promise because I want the people on the team to start thinking, where can I personally make a promise on this? And I want to separate that a little bit from a commitment. Commitments to me seem something we agree together, we strive to meet, but we know we can play with it. Whereas a promise, I want to make a personal sort of commitment, but a personal promise on that own individual. And that's going to help drive this up to hopefully be that more 90%, right? Because what I'm looking at is I want to get like over here that 80 or 90 or something like that % on that curve. I want to have very high confidence, whatever this point is. I want to say there's almost no normal way that we can exceed this point. And let me repeat that. No normal or fairly normal way to see this point. Now, I'm not talking about abnormal ways like meteorite comes down and blows up our project or something. I'm not talking about that. What I'm talking about is all the ways that we can normally screw things up, including misunderstandings, delays, all the normal things that tend to happen. We still shouldn't exceed that point, right? And this is where, again, a lot of my clients get in trouble because they want to make a promise estimate, but their idea of what is scary, what is high confidence is somewhat limited, right? Because they've often done things like they've exceeded their schedule by 100%. And so they think, oh, when we're first planning, let's just do 2x. Well, 2x, if you're already normally overrunning 2x, it only puts you down in here somewhere, right? You'll go up to 65, 70% maybe. You're not getting to 80, 90%. Or another example, a client that always overran his budget. And then he was saying, well, if we put another 50% on our budget, we should be fine. I said, why? right? You might land there, right? Because if you pick this point, you still may have, 65% or something like that. You may hit that, right? But if you really wanted to promise, if you want something you could guarantee, okay, that's probably not it. You need to go higher. You need to find a better multiplier for you because you really want to get inside 90% confidence. 90% confidence in many ways should sound unreasonable. It should sound like, well, there's no way it's going to take that long. And it should, because you should say 90% of the time, I should be on or before that number. I don't have to hit that number. I should be on or before. And we'll say, well, what if I put that number out there, they'll always be at least on it. And they'll probably even exceed it then because they had plenty of time to do that. Well, we're going to fix that later. So for those of you may be concerned about, if we tell them that this promised number, they'll just go to that number because work expands to fill all available time. We're going to fix that with something else here in a minute. So this is what I'm trying to get at here. I want a number that sounds unreasonable because it has such high confidence, but I don't want it infinity. And I don't want to go toward infinity. I want to just find, and I want to pull back a little bit. That's why we're talking about 80 or 90% confidence. And what I'm going to do here, I'll probably get some sort of multiplier on this. Okay. Now, this can be troublesome depending on where we are in the project. I wanted to share with you a cone of uncertainty that Steve McConnell put together from some of our clients. You can see it's 350 estimates from 5 different companies that worked with Steve. And what this graph is telling us is the amount of error that estimate was compared to what actually happened in real life, right? So at the end of the project, we normalize it down here at the end of the project. So this is what happened in real life. And so at a different point in the project, say at 20%, we can see that some estimates were overestimating, right? They gave them more time than they really needed by about 200%, or underestimating by about 400%. Now, the other thing on this graph that you might notice is the orange line here. The orange line represents the median. Now, the median in mathematical terms, just to remind a few of those, is not the average. The mean is the average. It's not the mode, which is the most common number. The median is you line up all the numbers of in this case, all the error rates, and you say you had 21, you'd find number 11, the one that was in the middle, and say that's the median. That's the number that if you line them all up is in the middle of the distribution. And you can see that it's going this way. It's below 0, which means that more stuff is down here than up here. In fact, there's a lot more stuff down there than up there, right? So we can look at this and saying, okay, what happened? Well, what typically happens, and happens to a lot of my companies, is they come up with a single point estimate. Right, that their estimate says our estimate is blank, right? And they come up with a day. I mean, maybe single point might be a quarter, but it's a single point estimate. A month, a week, whatever. They come up with a single point estimate. And to all practical purposes, that single point estimate is treated as a promise, right? We will hit this number. And what happens is that reality sets in, and they find out that their promise was off by, overestimated up here, maybe, but more likely underestimated. And you can see down here, we're looking at what, 700-ish%. Just a huge amount of underestimation on these things. Not that was uncommon. He actually got rid of the outliers, but we're seeing 400%, 200%. That's fairly common as underestimation here. Occasional overestimation. We had a few one at the beginning. We saw about 120, 150%, but most of it's down here because the median is below the line. So what's happened? Well, we said it. We thought it was going to take X. It actually took 4X. And so when we got the real thing, it was actually 4X from what we really saw. So what would be a promise number? If this was my cone for my company, what would be a promise number? Well, I could say, gosh, I think, right? I think it's going to take this, but we could see that if I want to make a promise and I don't want to be wrong, I might have to add a whole bunch to it just to get right where we wanted. And so a promise number here will be super, super scary. In fact, in this zone right here, this first part of the project, if I wanted to really make a promise number, it would be massively large. And so large that everyone would say, we're not doing a project for that much. And I would say, yes, that would be a stupid price to do the project, because making a promise out here when we really don't know because of our inherent uncertainty is completely crazy. What we need to do is we need to work our way into the project enough, and we can see around here 35, maybe 40%. We're down to a relatively small range here, and our median, right, is pretty close to line. That is, that the guesses that we have most likely, a few people whacked up, but the guesses we have most likely are not that bad off. That we can make a promise. In fact, even if we made a promise here at, about 100% or 60% over what we think, that might not seem so unreasonable anymore. Because promise estimates can seem unreasonable. In fact, if you think your promise estimate feels reasonable, especially early in the project, you want to really think if you have a promise estimate. Because 2x for me seems often reasonable for people when they often overgo 2x and they've lived through it to tell the tale. But that's not unreasonable. That's what you normally do. Unreasonable would be 4x or 5x. And you go, well, that's not reasonable. And it's like, okay, we're probably well safely into the promised land. It's not going to feel good here, but maybe by the time we get here, we can actually use it more interestingly. So when do we want to use promises? Well, we use promises estimates, of course, to make a promise. But the trick is that early promise estimates are not very useful, right? Because they're going to be super scary when we get that level of confidence that everything that typically can go wrong and has gone wrong on past work is going wrong on our work. So we really want to make these promises about 35 to 40% into the project, or the release, or whatever it happens to be, the scope of the stuff you're estimating. Why? Because then that uncertainty that we saw in this picture here starts to drop down a lot. That is, we're into the zone here where the range, and we can make a promise that has a lot more meaning. But what if they make you make a promise at the start? Well, okay, that can happen, right? We could be out here and say, okay, yeah, I see that range. You want to make a promise down here because that's where you're safe at, right? Because you can keep your promise pretty comfortably that way. And they go, no, there's no possible way we'll allow you to do that. We're going to force you to make a promise here. Right? Well, yeah, you can do that. That might happen. What I would suggest to you is to say, you know what, I'm uncomfortable making a promise there. In fact, I will not commit to any point in that range because it's unknown. What I will do is I will take that as a planning number, my next kind of estimate, and we'll work on helping to come up with a better commitment as we go forward. Now, you can force me into that, but I will continue to give you updated, true information about how this project is running, and I will try to control it by changing scope, by changing budget, doing other things that might be in my power to hit whatever number you've come up with. Okay? So we can have that conversation. So how do you actually come up with a planning number? Well, I suggest what you do is is that you look at your cone, start thinking about the things that go wrong, and come up with a multiplier of your own. It's the simplest way. So you'll start with your gut, and then come up with a multiplier. Or we can use the planning number we'll talk about next and come up with a multiplier from that. Either way, the gut multiplier will be much higher than the planning one. But if you do it on your own cone of uncertainty, it's going to be very easy to do. Right? Just come up with the first number, then use the multiplier. If you have a software estimation tool, that could work quite well as well, because that actually comes up with some, given your historical data, will actually come up with what your 60, your 70, your 80% confidence number, and then you can just go with that. Okay. So the second estimation type here, my promise estimates. These are really handy to make a promise on behalf of the team. You only want to do this when you have a small enough spread in your uncertainty that making the promise won't scare everyone away from the room. My next estimates are my planning estimates. My planning estimates, when we come to think about it, is going to be using one of these 2 points on the curve. The planning point, which we used to call, I used to introduce to you as the nominal. I'm renaming it the planning point now, because this is the perfect place to do planning. But we often start with the most likely case instead, because the planning number takes a little bit of math to get to. We might want to start with our best case. In fact, I like to start with my best case, then jump to my worst case, and then come back. And usually that's helped me find the most likely place, right? And then maybe from there I can get to the planning case. But we want to use the planning case because this is the number that we're going to plan against. And this is my reasonable number. Where my promise number was my unreasonable number, my planning number is my reasonable number. This is the number that people would say, okay, I can live with that. That sounds rational. Right? And especially if I prime them with a really scary promise number, they're often very grateful to come back to the number and say, okay, here's what we're planning to do. But remember, my planning number is still, even if I even get the right point, it's still 50-50, right? I'm equally likely to go over as under it. So what is it actually good for? Well, it's good for a couple things. One, it's really, really good for tracking. That is, if I want to track the team, I want to track them to the planning number, not any kind of promise in the future. Remember, I suggested that if we give the team the promise number and say, well, we have to deliver by this promise number date over here, what's going to happen? They'll say, oh, look, I got lots of time. I can then polish this up. I got all these other things. I can put this off for a while because look how much time I have, right? And then next thing you know, you've blown right past your date. It's like, What we want to do is use the planning number to track again. It's going to say, okay, no, we need to be done by this date with this piece of work. And they're going to go, wah! But you have to understand that we know that we're equally likely to go over as to be under. So we're not going to be holding you really hard to that date, but we're going to be constantly questioning you, asking you questions. And when you go over, we're going to understand why, so we can improve things in the future and come up with better planning numbers, right? But this is what we're going to do, because if we keep to this planning number, that means we have high confidence we'll deliver on our promise. So we track to the planning and we go to the promise as we move to the promise. It's also good for making decisions, right? Because it's a reasonable number to make decisions based off. And the kind of decisions we tend to make off the planning number is not when it will be done, because that's not the decision that makes sense. Promise number, we can always promise it will be done by, but the decision we're making at the planning number is like, what should we start with a budget? What should our budget be around, right? You might want to add a buffer to that. If we're looking at a couple different options, which way will be a better approach? If we're looking at different architectural choices, what might be our trade-offs, right? So we're going to be using this planning number. We like to use this planning number for lots of core decisions, even early on the project. Remember we talked about our friend the cone a moment ago? Early in that cone, the planning number, my reasonable number, is a number I'm going to start with. But I'm going to have to suggest to you, we're going to have to come back to this thing and revisit this throughout the project. All right. Now, when I'm looking at this, because this number here is kind of hard to get, I'm most likely going to start here. But if I start here, you notice that we're even thing. We're not getting a good even 50-50 at that point, right? We're getting 35, 65, 40, 60, maybe something like that. We're not getting the full 50-50 even good odds. And that might be just a little too pessimistic, a little too harsh on the team. Because it's like, well, if I use this number, we'll never hit any of the dates hardly ever, and everyone's going to get depressed, right? Because at 50-50, we should be early occasionally, or at least on time occasionally, right? Because it's a good 50-50. But if I'm down here at 35, I may not have the reasonableness to make it happen. So maybe I want to get closer to this planning number. How can I do that? Well, to do that, we actually have some math, right? There's a math and the thing called the Pert Formula. And anyone project managers out there might have heard the Pert Formula before. And this is the Pert Formula. It's pretty simple arithmetic, right? It's not even math. As my math major say, this is just arithmetic, right? So if we change it to the terms I like to use, we take the ambiguity point plus the promise point and 4 of our current planning point, which is often our most likely case still, right? And then we add them all together. And then we divide it by 6 to get the average. And what studies have shown is that this moves us closer to this true planning number, closer to this 50-50, because it tends to, we see our most likely case is closer to the best case than it is to the optimistic case. So it moves us that way a little bit. And that's what the Pert Formula does. It's a gentle nudge toward the worst case to take care of some of the biases we have when we came with the most likely case. And once we get this, it gets a term of its own. It gets the term expected case, is what it's often called. And as expected case, you can look and go, this is what we kind of expect to happen. Now, the trick is we won't be doing this arithmetic just once, right? I suggested a moment ago, if we look at a timeline of our project, right? Initially, we're at, and then if you think of our cone friend out here, right? We're at the wide end of our cone. We come up with our first estimate point, chug, right? And we come up with our best case. We come up with a huge multiplier for our promise case. We come back to our reasonable number, our planning case, do the math. We'll say, okay, we expect our planning number to be X. But we can't just sit there. As we go through the project, we'll have to re-estimate on a regular basis. And this is part of the deal of having a planning number, because we're going to say, well, I hope to never update my promise. Because remember, my promise was a huge multiplier, and I should hopefully be coming in on that. where I never need to update my promise except to bring it in, which no one ever argues, well, I will be updating my planning number because we will learn things about the project and I will learn what's going on. And so we'll have multiple opportunities to re-estimate and reset that planning number to reset our true 50-50. And what we'll typically see is that it'll approach our promise and hopefully we'll still deliver within or before our promise number. So this is going to be an ongoing activity. We're going to do our best case, maybe go out to our worst case, come back to our most likely case, use some simple arithmetic to come up with our expected case, which I'm going to then relabel to my planning number. So what do I do with planning estimates? Well, planning estimates I use to set budgets and schedules. These are the tools. This is the one point I pick to say, okay, here's what our budget should be. Here's what schedule should be. But I'm not making a promise. I got to be clear about this is our planning number. And I start having that conversation very early with all my stakeholders to say, well, we need a promise. And I say, well, I can give you a promise, but if we're early in the project, you're not going to like that promise. And it's going to be useless to you because it's going to be really, really big because stuff can happen. We've seen scope creep before. We've seen delays before. We've seen plagues before now, right? So we know lots of things can really muck this up. And so we're not going to pretend like that they don't exist in order to get this project into a number that you like. For a number you like, we're going to set a planning number, and I'm going to revisit with you on this planning number. I can give you a promise number if you like, but not yet. And if they say, no, we need a promise number, then I'm going to try to go back to my promise estimate and say, well, here's what I can promise you. It'll be on or before this number. But that's huge. It is, but there's so much we don't know yet. However, if you want to set a budget and schedule, I can come back to my planning number right now. And then I can use that planning number as a base to track against. We can say, well, we initially planned this, now we're planning this, and we can start talking about the differences. Because one of the cool things about estimates is that any errors tend to be whoops, I want to use a different color. Systemic, right? So if my planning estimate, if I planned that this first chunk would take X days and it took X plus 20% days, I can go, you know, I had a 20% error on my first segment. There's a reasonable chance that everything I did up to this point and planned in the future has that same 20% error. And so I can then base track and make better predictions in the future. And I can also use this, of course, my planning estimate to just even trade off between ideas. It'd be better to do this approach or that approach. And this is a really good number to use that because it has that 50-50. It's a little bit more than people's guts. We could do ambiguity checks on guts and maybe use that too. But sometimes we need to have more conversation, and the planning point will happen often more of those conversations. So that's why I like to use this one. So those are my three big points that I use almost all the time. I start out with the ambiguity estimate. It's a gut estimate. It allows me to find the work that's going on. Then I jump to my promise estimate, something that's really scary, especially early on. And then I roll back to my most likely and hopefully my planning estimate type to have those conversations about what the budget should be and how we should go forward. But now it's time for a bonus estimate, the go, no go. And this is interesting because on this one, I'm actually going to combine two different points on my curve here. I'm going to choose my most likely case, right, that one is our point, and my promise case. Because the problem I often see at the beginning of projects isn't so much as what is your final budget? Yeah, we love to know that. And I love to know the lottery numbers for the next big pick 6, right? Because then I don't have to keep doing webinars, I can retire. But what I really like to know is it even worth going forward? Is this even in the ballpark of what we care about? And so what I could say is, looking at our estimate with my most likely case, my promise case, I can say it's going to land in here somewhere, right? It's probably not going to be before this. I'd be very, very surprised, right? It could, but let's be surprised. But it's most likely going to land in this zone. The question then becomes, is knowing that it's going to land somewhere in this zone, if you want to be happy face, we can take the number close to this. If you want to be sad face, we can pick the number close to this. But in this zone, knowing it's going to land somewhere in this zone, is it worth proceeding a little bit, right? Because what's going to happen here, right, is what's going to happen here is that if we go through, we're going to say, we're going to keep updating this, say, in fact, let me go to my next page here. If we're in the column and look at our project timeline, and I'm starting out here, I'm going to say, yeah, we're going to land in this zone. Is it worth paying enough to get to here so we can see what the zone's going to shrink to? That's the question. That's what the go, no go questions ask about. Is it worth proceeding to the next check-in point? Because remember, I said that we should be doing our little estimate game multiple times throughout the project. Right? We should be doing estimates over and over again. And the question of the go, no go says if for this first estimate with the planning number, which is not super comfortable yet because there's so much uncertainty because we know it could be anywhere in this area, is it worth doing enough work to get down here so this area really shrinks? And that's what the go, no go is about. Is it worth investing in a short chunk to learn more? Because that promised number out here is going to be a number that's way too big for us to really like or live in. We'll want to try to drive that sucker forward. Okay? So that's my bonus one, go or no go. So when do you use go or no go estimates? I like to use it on that first part of the cone, right? I like to decide whether it helps to get me some work going forward. And if it's helpful for me to get that some work going forward, then I will go there. And then we'll come back to a more traditional estimation type. Probably if I can get 35 to 40% in, I'm certainly going to come back with my promise estimation type because that's what they wanted to hear all along. So my 3 estimation types. Well, it all starts out with this idea of a probability, right? That we have to have a probability to understand about what these estimation types even are. And from this probability curve, we're going to be picking some types. We start off by picking what I called, let me just go ahead and just draw it. What I called the my ambiguity. Ambiguity because the gut here says 25%, and that's not going to be happening on any project, but it helps me find ambiguity, especially on Scrum teams, and we're going to see that using story points and task estimate hours. Those are using the ambiguity point. From the ambiguity point, you can use a multiplier, you can use a, oh my gosh, what all things go wrong, to help try to come up with your promise point. What could go wrong at this point that normally goes wrong, often goes wrong, you know, not the weird things, but all the common things that go wrong, and I can still hit that number. That's my promise number. And we're going to see that hopefully you're looking like at 85, we'll just call it in the middle, between 80 and 90% confidence of the area under the curve here. The third point we picked was the most likely, or the nominal. I'll try to come back to that, but to do that, I usually get the most likely case before that. All right, and this will be my planning number. So when we erase nominal and turn it into planning. And this is a classic 3-point estimate, but you can see that each point is communicating a different thing. The ambiguity point is not communicating anything besides, do we see the work the same way? The promise point hopefully is promising something, saying we are high confidence that it should not take longer than this, given all the normal things that can go wrong here. Not just the normal way we do work, but all the normal things that can go wrong and have gone wrong in our organization. And then planning number. The planning number, here's we're communicating what we're tracking against and what we're holding ourselves to as a team, so that if we hold ourselves to this number here, we could be hitting this number down here. Right. So those are 3 estimate types. If you understand those 3 types, then you're going to be dealt with a lot less frustration by saying, wow, let's talk about the 3 types, dear stakeholder, and which one do you need? Because you probably need this one. Which one do you like? And which one are we going to use internally? Don't get confused when you see that happening. Because too often as people see these and they try to turn them into these, and then all heck breaks loose. So that is the 3 types. I'm happy to answer specific questions that you've had, hopefully queuing up for me, or take on scenarios. Ask me to estimate when the pandemic will be over. Ha 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 ha. I'll give you a promise number. I can do that. If everything goes wrong, the typically goes wrong in vaccine distribution, well, maybe sometimes in 2025. Jesse, do we have anything in the queue?
Earl, yeah, we do have a couple questions here. So I'll go ahead and ask a few of them. The first one, I think you touched on a little bit, but I'm going to ask it anyway. What if I take story points and say each point is about an hour's effort? Is that a good practice?
Yeah, unfortunately, that is not a good, well, it's a fine practice if you don't want to think about story points being ambiguity estimates anymore. If you want them to try to be planning numbers, then that's a game you can play. I think it's sort of an abuse of a story point because story points are supposed to be hopefully simpler and faster to do. But once you start going and saying a story point is an effort hour or a story point is a half day, Then what you're doing is you're asking people to estimate effort directly, trying to come up with planning numbers, or even worse, promise numbers. And really, we need to invoke more rigorous techniques on the teams that take longer to do if you want promise or planning numbers. It's going to take at least some math behind the scenes to do those things. And so to use planning poker as a way to come up with a planning number or a promise number is just not a good practice. You can do that, but you're going to have to do some math and other things to make it work.
All right, Earl, the next question is, why is the most likely not equivalent to the nominal? In other words, what's the definition of most likely?
Right. So that's a great question. Why is the most likely not equal to the nominal? It can be. It's big, but at its heart, let me just go back and sort of draw out my curve again here. Right. Is that when we're doing our points, we know how to guess this one pretty well. Our data shows that let me shoot that in blue. My data shows that this one, that what I call ambiguity, we're pretty good there. We're pretty consistently hitting that, right? And with a little mental effort, we're pretty good at hitting a promise number 2. The thing is that in here, we're not good at anywhere in between for the most part. We're really pretty crappy. So when we look at it is what people come with the most likely is, again, it's sort of like, well, I gave you this ambiguity number here, and I know that my gut is always optimistic, so I'm going to put a little bit more on that to the one I think is most likely. So the reason why the most likely is not hitting the nominal is while we theoretically call it the top of the curve, it's actually just somewhere in the zone, right? Because it's a guess. It's someone's educated sort of good guess. And this is where you'll see, especially managers, it's just horrible when I watch this happening in teams. I go to a company, I remember one company in the Midwest I went to, and the manager would go, well, you know, here's it's going to be, it won't be longer than this. And so my expert opinion is it's right. And they pick some point on the curve. Now, because this was their most likely. So it's a pick somewhere, a guess somewhere, typically that's close to the ambiguity, further away from the probability, but it's often still very optimistic. And that's why the most likely case is not the same as the nominal, because the most likely case still often has inherent optimism. Human beings, turns out, are very optimistic. We tend to go to that side of the curve regardless. And that's why ambiguity is so easy to come up with, because we are truly optimistic people typically as a whole. Now, you may have a curmudgeon on your team that's been pessimistic for about a decade now and will always give a massively large number. Okay. But as a general rule of thumb, human beings tend to be optimistic. And since they're optimistic, when they pick one from the zone, they tend to pick it closer to that, which means it's closer to the ambiguity, which means that it's probably not 50-50, it's probably 35-65 or something like that. And so we need to do some math to get closer to the 50-50.
Thanks, Earl. The next question is there a tendency to pick a planning number that is midway between the best and the worst case?
You know, I've been running a lab in our estimation class for a long time that asks them to do a 3-point estimate. And I got to say, only about 10% of the time do they pick a number right in between the best case and the worst case. And when they do, it's usually because they've only used 2x as a multiplier for the worst case. Right? They came up and said, oh, I think it's going to be 30 staff months. The worst case, I think, is going to be 80 staff months. So I'm going to pick 50 staff months as my most likely, you know, something right in the middle, or 55, whatever it is. And it's because they only did like a 2x or something like that on the worst case. But when they do a 3x or 4x, then I almost always see the most likely case being much closer to the ambiguity, because they don't want to say a big number. Right? They're just as scared as heck of them. So my first goal is always to say, hey, let's make that promise one a unreasonable number that anyone looking going, it can't take that long. And if you're at 90-95% confidence, yeah, it shouldn't take that long, right? Only once in 100 does it ever get past there, kind of thing. Or 10 in 100 if it's 90, right? Or 95, 5 in 100. But it means 90 are getting earlier. It would be really weird for one of those to go past. So, especially if we're doing a reasonable job controlling it. I mean, this is a project that had to be totally out of control the entire time. And so if we're doing a reasonable job of controlling it, we should be able to pull it in before that 90 or 80% confidence. So you got to get that when they're really feeling bad about it before you come back to the most likely. And so besides my class, I don't see it very often.
Thank you, Earl. Next question. What if the leader wants a promise estimate, but only gives us time for an ambiguity estimate?
Right, if they want to promise us. So here's where, if you have a couple tricks up your sleeve, one of the best tricks for this is to create for you and the leader, if you can do it ahead of time, what's called a standard estimation procedure, right? And usually if you do this before you get caught into that, what that does, it gives saying, well, I'd love to come up with an estimate. We have an estimating procedure that you and I have agreed to. Let's evoke it and come up with your estimate, which will save you from the ambiguity estimate. The other trick that you could do is to come up with a holy crap, I'm cornered multiplier. And so you might say, whatever I say, multiply by 3x. So this is something I do with my wife. If she says now to me, Earl, how long should it take? My gut estimate is this, and then I quickly put on the Earl incompetence multiplier. Where it says, I should only take 15 minutes, but I should double that because, no, this is that kind of work. I need to triple this work. So when I talk to her, I can say 45 minutes rather than the 15 my gut tells me, is that I probably will come on or before that so I can make it into a promise. Because that's what they're doing. They're forcing you into a promise, right? So you have your own internal gut multiplier. This is what people will do by themselves when forced to constantly be held to promises and have to get gut estimates. The third thing, and this is something we see in the training that we do, is just say, give me an hour. Or if an hour if you can get it. Even if it's 10 minutes or 3 minutes, even if you get 3 minutes and just say, let me think about this for 3 minutes, you'll do a much better job than if you're trying to pull that off in a 15, 30-second kind of range. Right. So if they're giving you any kind of time, an hour, something like that, just go through and what you want to do is you want to start listing all the problems that could happen. So an hour, just take and just list problems, because that will help compensate for your optimism. What are all the things that go wrong here that I want to at least think about? What are all the interfaces that we have to deal with that I just want to think about when I come up with my gut estimate? In that case, you'll probably be closer to your most likely number than you would be the ambiguity estimate. So even 3 minutes will move you closer to the most likely than the ambiguity one. We want the ambiguity one to be really cheap and fast.
Okay, Earl, here's another question for you. Is it worth looking at each estimate in terms of plus or minus a percent? For example, 100 days plus or minus 10%?
Yeah, so we're getting in here, how do we present the number? Because if we have the curve, right, and we want to pick a point on the curve, how do we present it? Here's my promise. So do we present it as a single point, X, or do we say it's 8 months minus, probably to our most likely, minus 5 plus 3, or you pick a point here and it's plus 3 minus 2. It depends what happens. Some organizations can get that and they can live with that, and that's fine. But what I find is that a lot of people don't get probability. In fact, I think probability is really poorly understood by the general population. As we can see in our national pandemic, the odds of this and the odds of that, we don't know how to talk about that very well. So when you say plus or minus X, what I like to do in that situation is to say, my estimate is, and then give them the promise one. And then say we could bring it in by X months. And then I take a list of actions that could be taken, and for each action, say A1, A2, A3. If these actions occur, we can save 1 month here. We can save half a month if this action happens, and 2 months if this action happens. So I list the actions that could bring me in from that promised number if they happen. Because what typically happens is that to come up with a number that the organization likes is that you have to make a lot of assumptions. We're assuming that this is true. We're assuming this is true. What this is down here is this is my list of assumptions that if they happen to turn out to be true, we will bring in the schedule, or we'll bring down the cost, or we'll deliver more stuff, right? But if these turn out not to be true, then we don't get that savings. And when the number they're listening to is the promise number. So instead of plus minus, I like promise, and then minus if I have to present it that way.
Okay, Earl, here's another question. Why do you say a good estimate takes only 15 minutes? Our estimates typically take weeks.
So someone has attended some of my training or watched my estimation class. Yeah, I often say a good estimate should only take 15 minutes. And the reason I say that is because if you're using a gut estimate, it's almost instantaneous. If you've already decided your multiplier at that point, that's simple arithmetic, right? And then if you're going back to your saying, well, I got my promise, I got my best, what's my most likely? We're back to guessing again. What I see that when estimates take weeks or a long time to do, they've stopped estimating and they're trying to do planning and substitute planning for estimate. That is, can I understand what's going to happen, right? They're looking at the future here. They're sitting at some point. Well, I can actually mark this up. They're sitting at some point and they're trying to look in the future and say, okay, what are we going to be doing 6 months from now? What are we doing 3 months from now? What are we doing 8 months from now? What are the little tasks under each one of these things? So when I add them all up, I get my total, right? Some sort of planning exercise. And this has two major faults with it. One, it doesn't deal with uncertainty at all, right? Because I'm basically listing all the things that are going to happen, and I don't know how to deal with the uncertainty in that kind of process, except trying to put on buffers. And then everyone's putting on buffers. And when you put buffers on each of the subunits, here's my little buffer on each of the subunits, and all of a sudden I'm massively over buffered and it's really too big, right? That's going back to probability theory again. That's one thing too. And the second thing is that I don't know any of this. I really don't know. I'm just guessing all this. And if I'm guessing in all that detail, why don't I just guess the whole big block of it with my most likely and make it much faster? In fact, if you follow a reasonable guessing process where you have a good multiplier and a good process, you'll make a better guess with the big blob of it, not worrying about all this detail, than you're trying to guessing all the little detail. So this is where I see people spending weeks, sometimes even months. They're trying to come up with detailed plans of all things they're going to do in the future, then try to add those up to come up with a number. And frankly, I've never seen this really work at all, because you're basically making stuff up. You're doing all these things you really don't know. You have a good hunch. You've done something like this before, but you don't know it. And rather than saying, let's base the estimate only on things that we know at this point, which is we're going to have this work. And this work is similar to a work we did last year that was roughly the same size. And that took blah. So we suspect it around the same size again until we learn more stuff.
Okay, Earl, I think we're almost at the top of the hour, and I know you have another engagement coming up pretty quick. So,
I do. Another client's going to
yes.
talk. We're talking about requirements.
Awesome.
So well, maybe we come back to another Q&A for requirements someday.
Yeah, thanks for the presentation, and thanks to all of the attendees here that tuned in. If you have or had any other questions that we weren't able to get to, or you'd like to learn more about how these concepts apply to your organization, feel free to reach out to me personally, and I can pass those along to Earl. We look forward to seeing you next time. And Earl, thanks again for the great presentation.
You're welcome. And you can also reach me at my email address as well, or as he's saying, hello at Construx. We'd be happy to hear from you. Good day, everyone.